Hi everybody, today we're going to continue to talk about graphs of trig functions by looking at tangent, cotangent, secant, and cosecant. As a quick reminder, we call cosecant, secant, and cotangent reciprocal identities. Cosecant of theta is 1 over sine theta, secant of theta is 1 over cosine theta, and cotangent theta is 1 over tan theta. Tangent and cotangent are also called quotient identities. Tangent of theta is sine theta over cosine theta, and cotangent of theta is cosine theta over sine theta. Let's start by looking at tan x. Tan x is an odd function. That means that tangent of negative x is equal to negative tangent of x. So if we take values that we know, like the tangent of 0 is 0, the tangent of pi over 6 is the square root of 3 over 3, tangent of pi over 4 is 1, tangent of pi over 3 is the square root of 3, and the tangent of pi over 2 is undefined, and look at the negative angles, we'll see that the tangent of negative pi over 2 is undefined. Tangent of negative pi over 3 will just be negative square root of 3, tangent of negative pi over 4 will be negative 1, and tangent of negative pi over 6 will be negative the square root of 3 over 3. Let's take a look at all of these values in a graph. This graph displays the 7 points that we had in the table. We can see what's happening from negative pi over 3 to pi over 3, but we get a little lost between pi over 3 and pi over 2, or negative pi over 2 to negative pi over 3, so let's add a few more values. By adding values between pi over 3 and pi over 2 and between negative pi over 2 and negative pi over 3, we can see that the closer and closer we get to either plus or minus pi over 2, the values of our functions get higher and higher. In this graph, I put vertical asymptotes wherever the tangent of theta is undefined. This helps us see the period of tangent theta is pi. Tan theta has x-intercepts at k pi, where k is an integer, and you can see that asymptotes occur at pi over 2 plus pi k. You can also see that the range of tangent is all real numbers. If we flip this over and look at the cotangent of x, we see that we also have an odd function. On the graph, we can see pi over 4 is 1, and negative pi over 4 gives us negative 1. For cotangent of x, we have asymptotes at k pi, where again k is an integer, and the x-intercepts occur at pi over 2 plus pi k. Just like tangent, the range of cotangent is all real numbers. We're going to use the graph of sine x to graph cosecant of x. Cosecant of x is 1 over sine x. Since we can't divide by 0, I've put in vertical asymptotes wherever sine of x is equal to 0. I added points at pi over 6, pi over 2, 5 pi over 6, negative pi over 6, negative pi over 2, and negative 5 pi over 6. I want you to think about the fact that cosecant is 1 over sine. To graph cosecant, we're going to take the y values and find the reciprocals. When we connect the dots, we see that we have curves between the asymptotes. Curves that face up have a minimum value of 1, curves that face down have a maximum value of negative 1. This shows us that the range for cosecant of x is negative infinity to negative 1, union 1 to infinity. We can use the graph of cosine of x to graph secant of x. I'm going to start by looking at the x-intercepts of cosine of x, and wherever the x-intercepts occur, I'm going to put vertical asymptotes. Again, I'll add points to my graph, and to find the y values of secant of x, I'm going to do 1 over the y values of cosine of x. Again, I have curves that fit between my asymptotes. Just like cosecant, I see curves that go up have a minimum value of 1, and curves that face down have a maximum value of negative 1. This says that the range of secant of x is negative infinity to negative 1, union 1 to infinity. I encourage you to spend some time looking over all of the trig functions. Look at the similarities and the differences. Discover which functions have the same domains, ranges, periods, and asymptotes. This will help you work through the functions and prepare you for the transformations.